Good afternoon. Yes, it's afternoon, everybody. I start these streams at random times. How do I start it? Is it morning, afternoon? I don't know. Anyway, welcome to yet another stream. What are we doing? We're evaluating GUI frameworks. Which one are we looking at? We're looking at Cushy. Specifically, though, we're doing something a little bit weird today. We're looking at mixing ELM architecture with reactive GUI frameworks, which is it's an odd place to be. It's an odd place to live in. Normally, you either have a GUI framework which is using the ELM architecture entirely, which basically has a update method on it, which is called by the framework, which then comes along, updates the view, recreates the view, updates the state, and then the view gets recreated based on the updated state, and interactions trigger messages, and the messages are what is handled by the update, and there's this cycle that goes around. Right. Reactive frameworks, on the other hand, just have like callbacks on everything. So you create a dynamic thing, and every time you use that dynamic thing, all the subscribers of that dynamic thing get updated when that dynamic thing changes. And they're used in views, basically, or on callbacks and all this kind of stuff, right? But we had some issues. One of the really hideous things we had was nested closures and lots of copying. So let's have a look. Let's have a look at things. Here we go. Right. So this is our application that we've been trying to create. And this is just like a test application for evaluating GUI frameworks. The requirements for which are here. Yeah, thus, where is it? Requirements, right? Let me just put it in this mode. Yeah, requirements. And we're trying to fulfill these requirements in every framework that we try, right? But yeah, so yesterday I went over some of the problems that we were having with using solely reactive stuff, reactive ways of doing things. Let me just refer back to a commit or branch which had this this type of code in it, right? Where's my branch thing? There it is. Can't see it for looking sometimes. Right, examples. So before the ELM stuff that we've done, we've got this example. And one of the tabs, for instance, this one, and when I say tabs, I mean like one of these things at the top here, right? It has an OK button, and it basically needs to create a new document and then add that to the tab bar. Right. But the new tab, by doing it here, it means the dependencies of this file. It has a dependency on the tab bar itself. Right? It has a dependency on all the different types of documents that you could possibly create, and the documents as well. And that doesn't seem right to me. Not only that, it needs a context which has the ability to get documents from it and the ability to get the tab bar from it. And arguably, the tab bar shouldn't even be in the context anyway, right? And the way that this pans out is that you have to clone things, and then in your callback, you have to then use these cloned things. And it's just like excessive cloning going on all the time. Another way that this manifested itself, if I can remember where it is, Yeah. Is it this? Nested. Ooh, well, code. Where was it? It was another callback. Which callback was it? It's the toolbar open one. Yeah, that was it. This one. Here it is. This is another way that it manifests itself. So we're creating a toolbar which has an open button, which when you click needs to clone a bunch of things from the application state, which then creates a file picker, and in the pick file callback it has to clone all these clones. Not only that, yeah, well, maybe it was only that actually. Yeah, and all these methods like open document, for instance, you need to pass all these parameters around all the time instead of just accessing them from the application state as a mutable self, for instance. So there's closures everywhere, so it's a bit of a faff. Well, how else did this manifest these issues that we had? Yes, the new tab itself. Clone. Where is it? Oh, where was it? There was a place where it's cloned self. I'm trying to remember where it was. I think it was the tab bar itself, yeah. Yeah, this is another place where it manifested itself, this problem. So the tab bar needs to be cloned, which means everything in it needs to be clonable. Right? But they don't really need to be clonable. It's only so that the on-click handler of the close button on the tab can call self.clone, so that it can then call a method on itself in the callback handler for the on click. Because basically you need to call this close tab method, which takes a mutable self, but you can't have a mutable self because you don't have self in a callback handler. So you have to copy this self and then do it like that, which is, or clone the self. Yeah, it's not pretty. It's not pretty at all. Anyway, so these were some of the issues that we had. So I had a stab at fixing it using the ELM architecture pattern. So let's bring up my notes. So the idea is that you emit messages on UI interactions instead of running code directly in callbacks. That's one of the fundamental changes. So the basic UI flow now is then interaction from a user. That creates a message. That message results in an action when it's handled. That action then causes state to be updated. The state update procedure for whatever it is that needs updating essentially updates a bunch of dynamics, and then Cushy uses those dynamics to update its view tree and re-render everything. So, you know, the entire flow isn't totally hideous, I don't think. So that's what we've ended up with anyway. So yeah. So let's go over some of the positives and some of the negatives. So what does it look like now? Here we go. So given those same things that we were just looking at, let's start at the last one first that we looked at. not that one. I'm looking for tabs. This one. So now the tab bar isn't clone, right? And it's just got, you know, things in it like a vector of stuff and ref cells. There are still some dynamics in these because these things are used by the view. But when you've got data that is not needed for the view, then you don't need to wrap it in a dynamic anymore. Great. Let's look at the on-close callback handler, because that's where a lot of this all started from. So the close button has now got the X, and it has an on-click handler which uses the message, which is a dynamic, and we rely on Cushy to update the dynamic and notify all its subscribers accordingly, of which there is only one subscriber. And it uses force set. Now I had to add force set because if you use set and you do the same thing twice, the subscribers that are using the message don't get notified. So if you want to say press the home button twice or the open button twice to open two separate files, for instance, the second one wouldn't work because it was using partial EQ to test for equality. So there was a way of doing that in Cushy that basically doesn't require partial EQ. So we can see the set one has some documentation that says it needs partial EQ. So I implemented this, which basically does what this documentation used to say, as in use mem replace on it and discard the old value. So we did that. So we go force set and then we go tab message, tab close with the tab key. And where does that message go? Aha. Yeah. Are you ready? We're going to go down the rabbit hole now. Just be warned. So our application starts up, right? What does it do? The first thing it does is to create a message, and that is what will end up having this message. But this message is a tab message, and this message here is an app message. So there needs to be some wrapping of a tab message into an app message. And if we look at app message, we'll see that yes, indeed, there is a tab message which takes a tab message. Fine. So we got a message, and then we create a channel on which we've got a sender and a receiver, and then we create an executor which can execute async things. The executor isn't entirely required for this whole process, but I've also implemented async functions and so on, and it's not required for the tasks, but it is sort of required for. It's not required to have tasks rather, but it is required if you want to have something else on the same thread which pushes the message that you've just changed into some dynamic again. So it's a little bit funky. So yes, we create an executor, and this executor is literally just this. It's really nothing funky at all. All it does when you spawn a task, it just goes async to task spawn, and you get a future out of it. Fine. So it's very simple. So it goes spawn, and it spawns a dispatcher. And the dispatcher takes the receiver, and it also takes a clone of the message. And this dispatcher's job is to basically run in a loop and wait for the receiver of that channel to receive a message. And when it receives a message, it just goes force set on that message. And that's all it does. That's all it does. But it's an async function. And this select calls await. So it sits there, doesn't consume the CPU, it just waits for a new message to appear. So that's what dispatch does. And then we've got runtime. So we create a new runtime using an executor and a sender, the other half of the channel. And this has a run method in it, which was shamelessly borrowed from iced and with the action handling removed. But it's very trivial. It basically takes the stream, which is that second argument, which is the sender implement stream, and every time that sender has something that's ready, it then forwards it and then maps the result and then spawns a task with this future. So it allows you to process a stream of messages, basically. Yeah. Okay, so that's a runtime. And then all the other stuff is the same as it was before. Pretty much. Yeah, all the other stuff is pretty much the same as it was before. So where we've got our message, oh yeah, except this bit. So where we've got our message, and this is the dynamic app message, every time a new dynamic app message comes along, it locks the application state and calls update with the updated message. And then you get a task back. And this is what I was saying, we've got this task thing, but the task isn't entirely required, but my update method now allows me to create async tasks, which I can then spawn on to the executor. Yeah. So, yeah. So that basically ends up, that's how they get there, basically. So this update method then needs to process that and then delegate it to something. So we were looking at the tab bar, and it's emitting a tab message. Right, but it's not quite as simple as that, because yeah, where does the code go? How does it work? How does it work? Right. Yes. Okay, this will become slightly clearer in a minute. Yeah. No, it will, honestly. Yeah, this is what I was trying to find. So if a tab message is emitted, it goes on to a dynamic tab message. And when that dynamic tab message gets set, it then gets wrapped in an app message, and then for set on that same message instance gets called, and then you end up back in the this closure. This closure. Right. So let's look at the update method. So the update method goes, okay, given an app message, if it's of a kind app message tab message, then lock the tab bar and call the update. And this returns an action now. An action is a dumb class, very silly thing, which just wraps T. But we needed it, at least I think we needed it, so we'd include it in the trait signature for tab, which will be more obvious soon, hopefully. So then the update method on the tab bar then goes, well, okay, now I've got this tab message. If you're closing the tab, which is what we said we were trying to do, right? this thing on the close button, right? If we get one of those messages, then we've got a mutable self here, and we can just call close tab, which can do all the job of closing tabs. Great. That then gives you a tab back, and then you create a tab action that says the tab was closed, so that if anyone wants to know what was closed, they can look at it. Now you might also remember from the other day that each of the tabs had an on-close callback, right? And when we created tabs, we passed in a closure, which was the on-close thing. That's gone now. Disappeared. We don't have it. Add tab. Add tab doesn't have that anymore. It's gone. Right, so bear that in mind. So we get a new action of tab closed, and then we return that. So if we go back to the calling code for this, the app then goes self on tab action with the action. And then we've got a mutable self still here, which means we've got access to all the things inside the application state, such as the documents and the tab bar. Right. So now we extract the action from the action. Yeah, we just get the inner thing that the tab action wraps. And then if the tab was closed, then we go, okay, tab was closed. And if it was a documents tab, there's some extra handling that we needed. And that is to remove the document from the list of documents. Thus. And this basically was what our on-close callback handler was when we were calling add tab before. And that's where it ended up. Inside the application, which owns the tab bar and the documents. And this all makes a lot more sense now. So the dependencies from main point at the things that it uses. And it's not all over the shop like it was before. So I'm much happier with the dependencies on this. Right, so, but, not quite finished yet. So it handles the tab closed, and it returns task none, which means nothing happens after this. There's no additional processing to do. But sometimes when you're handling messages, you need to have something run in the background. So for instance, and I'll give you an example of this. Right. So what we've got, when we open a file, imagine this wasn't opening a local file and it was making an HTTP request. Now what it means is that you can make that HTTP request asynchronously and get the data back and then show the tab, right? For instance. But to simulate slow loading of this, we're going to open an image file, and then you'll notice that about 500 milliseconds later, the image was finally displayed. I'll do that again for you, like so. And we've got that same sort of slow loading, simulated slow loading in the text ones as well. So with these ones, it creates the box and then it gets filled in. I'll do that again for you, like so. And that's because the opening of the file is now happening asynchronously. When that asynchronous thing finishes, it needs to emit a message to say that that asynchronous thing is finished. Right, so let's have a quick look at how that works, because it's a bit funky. So we've got our document tab. Right, yeah. Okay, let's have a look at the image document. So the image document has got a texture which is optional. So when it's first created, it's defined as none. There's no texture. And then when we call either new or from path, we get no texture. And then we need to call either create or load, which does the job of either creating an image or loading an image. And this is where the simulated slow loading is coming from. And we've got an async function which basically takes a path and emits a result. Now, how does this get called? Let's dive into this a little bit. So what happens now is when you call new or from path, let's deal with the from path one. This is for like loading one. When you call from path, it returns an instance of self and a message to send once when the new instance has been created, basically. So the message that we're supposed to be sending is this one, load. So let's see where this is called. So we go image document from path, and we get image document and a message. And we put the image document in a document kind, and then we create a tab for it. And then we create a tab message of a tab kind message with the tab key that we just created, which is a document tab message. Yeah, it's a bit rappy, isn't it? Which has a document tab message of an image document message containing the message that we returned from the from path method. Okay, so there's a lot of layers of messages there, which it's a little bit oniony. You've got to peel back all the layers as you go further up the hierarchy of objects and components, as it were. So this open document method basically gives us an OK with a message. It gives us an app message back. Where is this called? That is called here. It's called in two places, actually. That one. And this is called because the closure of the file picker emits a message that says file opened with a path, which I can show you later if you're interested. Yeah, so open document gets called, and this then immediately creates a task which emits the message. So that message then gets processed by the application state, which is going to be a tab message. So then it goes update on that, and the tab, it's going to be a tab message of tab kind message, and then it's going to call update on that, which is then going to be handled by the document tab message, right? And if you're an image document and you've got an image document message, then you call the update method. And if the message is load, then the action you should take is load. So then you get an action which is load, which is this one. I told you we were going down the rabbit hole. Right, so if we're supposed to be loading a document, then we create a new task using task perform, which takes an async function with the path, and that gives us back it gives us back a result. Right. That result right, needs to be converted somehow. So the perform method takes two arguments. It takes the async function, and then it takes another function which deals with the result. And the way that it deals with the result is to create a message with that result in it. And we've not got any error handling here yet, but we can add it. So then it creates a new message to say it's loaded. So then you get a message with a lazy texture in it. Great. Then what happens? So we've got a message. Well, let's see how the task gets run first. So this task is then put inside an image document task action. And then the calling code takes that action of a document tab action and wraps it, or maps it rather, into a tab kind action with the action. Right. And the calling code of this, and that's then the return value of this. So we get an action of a tab kind action. Right. Which then gets mapped into a tab kind action and returned as a tab action. And then we get the action. And then we got the on tab action. And if it was a tab action, then, oh, where are we? Then we map it. Oh my god, I'm getting myself lost here now. What happened to it? That's right. So we still get a task back from this, but it gets mapped into a app. Well, hold on. We get a task, but it gets mapped into a task that creates a different kind of message. Right. So this returns a task. On tab action returns a task. That's the important bit. And this update returns a task. And that task is what is pushed into the runtimes stream in order to provide the output. And then the runtime spawns that. And then that is then handled essentially pushed onto the channel which had a sender and a receiver. So then eventually the receiver receives it, and then that message is then updated, and then control returns to this again. Yeah. I told you we were going down the rabbit hole. That's quite the rabbit hole. It's a little bit convoluted, but it's not entirely beyond the wit of man to understand it. There are quite a lot of moving parts, but each of the individual moving parts are sort of self-contained and fairly isolated. There's just a lot of nesting going on. Essentially, the nesting is very, very similar to the nesting in iced. The nesting in iced, if one remembers from the diagram that we had, looks like this. This is iced. This is not what I've just talked through, but most of it is exactly the same now. Except instead of having an iced runtime, you've got the runtime that I created this morning and yesterday. Plus the Cushy dynamic system, which basically updates the views. But the whole message processing and wrapping things in actions and all this kind of stuff is is identical to this. Curious. So it's no worse than iced, and it's no better than iced. That's an interesting point to make. The whole message processing system is identical to how it worked in iced. We're using the same. We're using an API with the same set of methods for tasks. We've got a very similar one for the actions. All the messages are identical. They're literally like copied and pasted from the iced example that we created, and it works exactly the same way. The difference is what happens in the update method and how the view and the view tree gets recreated by Cushy. That's the main difference. That's the main difference. So essentially we could replace this iced runtime box with like app runtime plus Cushy, and it would look like this. Yeah, so there we are. Interesting, huh? So let's go back to the list of things and go over the positives. Yeah, so the code ended up being in the right place. So instead of the new form knowing about a tab bar, and it's got no business knowing about a tab bar whatsoever, right? It now just sends messages. And the code that needs to access the tab bar is not inside the new form, which fixed the dependencies, see above. It avoided all the callbacks that were cloning all these dynamics. All that clone stuff has disappeared. An example of that, for instance, if we go into the main method and go, let me see if I can find it. There's quite a lot of code that I've written for this, surprising amount. Where's the file picker? Let me just see if I can find the file picker bit again. This one, there it is. I knew it was in here somewhere. Right, so the callback for the file picker now doesn't have to clone anything else other than the message. Right, previously it was having to clone a bunch of other things. And we were having to clone the documents and all this other stuff as well. It was, yeah. So we've got rid of all that. And the new tab, the handler for the OK button, is now just emitting the message. So all the code that was in this on-click handler is now moved into two places. One where it checks the validations, and the other place is in the main where we say create document. Right. So this create document now, it's much simpler. It doesn't need to pass in loads of random things and copy the tab bar and copy the documents and all this kind of stuff. It's basically just got access to self documents and it's got access to self tab bar. Because this used to be a method that was just a function rather than a method on app state. So yeah, so that was interesting. Then what? Yeah, it avoided putting too much state in the context. So let me give an example of that. So we had this context, right? And now we don't even have the tab bar in it, like it should be. Fantastic. So that was good. Avoids having to put clone on types that use my callbacks. So that was the tab bar. And this tab bar now no longer has clone on it, which is good. Shouldn't be cloning it. Shouldn't need to clone it. The implementation I've done provides a way to run async code, which we didn't have before I did this. Probably there was other ways to run some async code, but how, I don't know, because I never tried. But it was a positive of trying it anyway. So it allows you to create, and the next really good thing about this that I'm going to show you now, it allows you to recreate the application state by emitting a series of messages. As I mentioned yesterday, the reasons why you might want to do this frequently are 1, when styling widgets, and 2, when debugging. So say you've got an application which has got a bug in it, and you have to launch the application, you have to go File and then Open, and then you have to scroll through the file and then select some object and then do a bunch of user interactions with it, and then you get a panic or something like that, right? Because now all of the user interactions are driven by messages, it's possible to start the application up and just emit a sequence of messages. So when you're debugging, I don't know if you used a debugger before, but I've used one a lot. Often what happens is that you recreate the state just before the bug occurs and then start stepping through the code, and then it crashes and you're like, damn it, I didn't find the code. And then you have to go back, recreate the state again, you restart the program, recreate the state again, and then start step throughing it again. And it's really annoying to have to do this. It's very time consuming. So anything that you can do to make life easier when debugging is good. One of the other place that you would use it is when styling. So if you've got an application which doesn't have support for hot styling, shall we say, like HTML in a web browser like Firefox or Chrome does with a little inspector that lets you fiddle around with things, or Visio, which allows you to reload CSS files for the style of it, right? If you haven't got that, then you have to start the application up, get to the thing that you want to style, which might involve clicking on a few buttons, and then looking at it and going, oh yeah, I need to fix this, making a code change, rerunning it, and then clicking on the same things to get to that state again. So for example, say we want to run the application like so, and we want to go new, and we want to go OK, and we want to make some styling change to this, right? I don't know, like the alignment or something like this. That means every time I make a change, the process is go to the new thing, futz around with the styling code in here, right? Run it again, move the window over here, go new, and then do the interaction, and then go, no, it's no good again, and then do it again. But now what we can do, haha, the icing on the cake, here we go, is this. We can say, when the application starts up, emit a message that says new is clicked. Then somehow find the tab that was just created using a little bit of code, which normally is probably trivial. And then emit another message, which is the tab message, of the tab kind message, of the new tab message, of the OK clicked, which is another user interaction. This is a user interaction. This is a user interaction. Right. So now what happens when you start the application? It immediately goes to the place where you want to debug or style. Happy days. Look at that. Cool, huh? I'll do it again so you see it. Boom. It's just there. I'm not clicking on anything else. My window's opening somewhere up here, but I'm not clicking on anything else. Yeah, so that's pretty neat. That's pretty neat. And obviously, if you had a lot more steps than we do just here, then you'll be happy for a system that allows you to do this. So yeah, back to the list of things that we liked, didn't like. So that's that one. Let's deal with the negatives. There was some unwrapping of nested messages and actions, as in, you know, this, which is arguably more complicated to understand at first glance, because you have to trace where all the messages go, right? But at the same time, you don't have to deal with some of the other things. So you're like, well, you know, I didn't have to clone a bunch of things that I need to mutate, and I didn't have to wrap those things that I need to mutate in dynamics, and maybe now there's also less pressure on the list of dynamics that the framework has, right? Because somehow it's got to have a list of dynamics and it's got to iterate through all of them to work out who the subscribers are, right? So if there's fewer dynamics, surely the thing's going to run faster when the dynamics change. I don't know. I don't know about the implementation, but it might. It's possible. So yeah, that was a bit. Yeah. I mean, there's a reasonable amount of boilerplate code. What do I mean by the boilerplate code? You know, perhaps we can solve some of this with it's not really boilerplate code, plumbing code. Plumbing code is different from boilerplate code. Boilerplate code is the same thing that you have to keep typing all the time, and it's no different every time you do it. Plumbing code is what makes everything fit together. But it's just plumbing at the end of the day. It's just like making connections from, you know, one place to another, right? So you've got a bathroom and you've got a boiler, and there might not be, you know, you need water in the bathroom, so you've got to connect a pipe between the two. Plumbing. Similarly, in code, plumbing code, in this now it looks like all these update things. So we've basically got, you know, the update method, and there's various bits where we have to wrap things and map them and this kind of stuff, right? That's the kind of plumbing that there is now, but it's not totally hideous. I'm going to also write down here, list of user interactions is clearly defined in a single place. Well, I guess it's not really single place. Because the tab bar has interactions, right? And then the tabs themselves have interactions, and the documents have interactions. But they are clearly defined. When I say they're clearly defined, I mean they're clearly defined because there is an enum. So these are the interactions. Now, what we could do is rename the word message to interaction. Because when I was doing iced, I don't know, a week or so ago, before I started looking at Cushy again, I thought that message should probably just be called interaction. I might try that, see what it looks like. Probably going to be easy to understand and probably will prevent people from accidentally misusing it. Okay, so the text ones look like this: load, loaded, and create. The toolbar ones look like none, open clicked, home clicked, new clicked, close all clicked. Right? They're clearly defined what you can do. Inside the application itself, the interactions are tab interaction. Yeah, I mean, if you read messages interaction, tab interaction, toolbar interaction, or file is opened. Seems reasonable. Yeah. Document interactions. What do they look like? You've got an image document interaction or a text document interaction. Pretty clearly defined. What you don't have to do is this. You go, where's the view method or make content? You know, we could rename this to view. You know, then it would be more like iced for people thinking about this that way. You know, where you don't have a mutable self. I might do that as well, actually. Yeah. So what you don't have to do is find your view method, the thing that creates the view for your component, and you don't have to scroll down through it to find all of the callback handlers on all of the buttons and things that you're creating. And yes, I haven't transitioned all of them just yet. So yeah, there's not too many interactions with this. The OK one being the main one. Right. Yeah. Interestingly, in iced, where we had our new form, right, one of the interactions for this was name changed and kind selected. Now we could add these and everything would be fine. That would all be fine. Let's look at the text document. This is the interesting one. So in iced, we had a text document message where the thing was edited and you were given an action which you then had to pass to the editor. So let's look at the handler for this edit one, right? So the handler for the edit one, you basically need to take that action, and if there was, and then you basically have to call perform with the action. So to make the iced editor widget work, you have to pass the actions that it creates back into itself. So you have to sort of wrap it in a message. Interestingly, with Cushy, you don't have to do that unless you really want to. I find this interesting. So what do I mean by that? So let's take the new tab for an example, right? In iced, we have a text input for name, and it's got on input, and it's got new tab message name changed, and this takes a string, right? So this message gets emitted when the string is set or changed, right? So that then needs to be handled by this, which basically is handled in the update method, which then takes the name out of the message and updates name in self here, right? So we've got this self.name and where we've got a string, right? With Cushy, you can emit a message if you want to, if the text input is changed. But if you don't want to, you don't have to add the essentially plumbing or boilerplate code. In this case, it feels more like boilerplate code. But I don't know, maybe it's plumbing code. It's somewhere between the two, I think. But you don't have to add that unless you need to. So what does that same thing look like in Cushy? So the new form has a name which is a dynamic string, right? And let's see how and where this is used. So this name thing is used here. So we create an input using a clone of the dynamic. And we don't have to add an onChanged event or message. We probably could. On key, I don't know. Yeah, so there's an on key method in Cushy, which is probably similar to the on changed thing. But we didn't need to handle that. The framework does it for us because it's dynamic. So it updates the view when you type into it, and yeah. And then when you actually need to use that value that's in this name field, it'll just be there for you when you want to use it. So we didn't have to create a message that wraps the value, which is interesting. So when we create the document, for instance, if everything is valid, then we just get the string out of it and give it to the action. And that's the same with the directory and the kind as well. So we didn't have to add wrappers for each of these. So we didn't have to add this one. Well, we certainly didn't have to add these ones are slightly different because it uses the file dialog thing to do it. But we didn't have to add these. So yeah, so that's an interesting. So let's write that down as a positive. I think that is actually positive. No need for plumbing / boiler plate messages when on forms, I suppose, on forms. E.g. an input field. No, let's say text input field. So yes, that was interesting. This is an interesting list. This is an interesting list. Like, I'm struggling to find negatives to this. Okay, let's say. See, I don't know. I'm kind of tempted to write additional complexity, but at the same time, I mean, is it more complex than just using Cushy itself? I don't think it is because of all the dependencies and all the things that the positives fixes. So yeah, I can't really write additional complexity there. Yeah. Okay, I suppose you have to know about more things rather than what the framework just provides you by default. Okay, we'll give you that. So what do we need to know about? We need to know about messages and interactions, actions and tasks. It's not hideous though, I mean really. And I suppose it requires a small runtime. And it is small. It's really like, let me just show you the amount of lines of code for this runtime that we've created. We've got the action, and I can actually delete these because I don't need them. So the action is basically this, which is 20 lines of code. The task is a little bit more involved. But again, this isn't hideous to understand. 90 lines of code, so 110 lines of code. Oh, I can delete this. Oh, great. Okay, and then we've got a runtime, which is 80 lines of code, and that basically has a simple executor, the thing that processes the futures, and the thing that processes the messages, and some way of creating streams. And then in the actual main application itself, there was, I suppose, this bit of code to create the runtime and the executor and so on, which probably could be made generic and put in a macro or just a method or something, really, probably. And then for each type of message that you have, you need to have the you need to do the mapping and conversion and pass it to the runtime. But it's not totes hideous. Yeah. So I wanted to go over that today with what I've done. And it does indeed it does seem to work, and I haven't yet been able to make it crash, which is good. I mean, I can just get straight back to like this bit, which is great. So, we'll open the documents like we could before. Right, and we'll use the new form, and we're going to say test 1. Oh, my phone's ringing. We're going to select a directory, and we're going to say OK. I've got a dentist tomorrow. And, it works. And then I guess if we close it all and restart it again, we're back to the same bit again, but we've also got the things that we had open a moment ago. So it does indeed work. Yeah. So let me know what you think about this in the comments. I'm very curious to know what you think. Yeah, very curious. Like, am I mad for trying this? Because I'm seriously considering using Cushy for my project. There's a few more things I need to try on it before I make the decision, but I'm seriously considering it at this point. Anyway, yeah, so just remember, folks, Sony software, how hard can it be? We'll find out on the next one. See ya.